All right. Hey guys, hopefully this is the last day of a video lesson for me, but today we are going to finish lesson 5.2, which we started yesterday. So today you are going to want your math book again. You're also going to want your calculator out and ready to go and your notebook. So have those couple things ready. All right, today's learning goal is that I can graph a function. So yesterday we filled in function tables. Today we're actually going to make graphs from those function tables. So as a quick refresher before we get going, we just need to make sure you remember how to graph points. So if I give you an XY coordinate and I ask you to graph it, remember the first number always tells you to go left or right, and the second number tells you to go either up or down. Okay, if it's positive, up, negative, down. Okay, so if I give you this first coordinate, -2, 3. All right, well, my first number tells me left or right. So I'm going to start at the origin. So I'll start kind of right here. And since it's negative, I'm going to go left 2. And then the second number tells me up or down. So I'm going to go up 1, 2, 3. And I'm going to put a point right here. So that is -2, 3. All right, my second coordinate is 4, -3. So again, I'm going to start at the origin. So I kind of start right there. And I'm going to go right 1, 2, 3, 4. And then down 1, 2, 3. So that's 4, -3. Now remember, that's different from slope, because slope, now if I asked you to find the slope of that line and I connected it, now I would do my counting. I would say, oh, it's down 1, 2, 3, 4, 5, 6-ish, and then over 1, 2, 3, 4, 5, 6. So it's down 6 over 6. So slope is the opposite of graphing points. So we're going to use graphing today as we look at functions. So just as a quick refresher from yesterday, we did function tables yesterday. So I would give you a rule or a function, and we would give you some inputs, and you worked on finding the outputs. So let me just do one just to make sure you remember how to do it. So basically, I'm taking this number, -3, and I'm putting it right where the x is. So I would write 3, parentheses, I plug in a -3, and then -2. So wherever that x is, you always want to make sure you put some parentheses. So 3 times -3, that's -9. And then it says -2. Yesterday I talked about you should add the opposite. So -9 and -2 is -11. So I get an output of -11. Okay, if I plugged in one more, let's just plug in 5. So again, I would start with 3, put parentheses for my x, -2. Instead of an x, I'll plug in a 5. So 3 times 5 is 15. -2 gives me 13. All right, so yesterday that was kind of our learning goal. Hopefully you felt pretty good on that. So why don't we open our book to page 266, and now we are going to learn how to graph functions. All right, so everybody, I'll give you a second to get to page 266. It's kind of up here in the corner. All right, so it says, the graph of a function is a set of ordered pairs consisting of an input and the output. So today we're going to be looking at linear functions, which we worked with last chapter. We know all lines are in this form, y equals mx plus b. That's going to make a line. So if I give you this function, y equals x minus 1, I know that's going to make a line. Okay, so they made an input-output table here. They already made it for you. Now from there, basically I just have coordinates. It's kind of like putting parentheses and a comma right in between. So my first coordinate is 0, -1. My second coordinate is right here, 1, 0. My third coordinate is 2, 1, and then 3, 2. Now all I had to do was graph those, which they did. They went 0, -1, they put here. 1, 0 is right here, 2, 1, 3, 2, and I graphed it. Now, I could confirm that I did that correctly by thinking about what I know. I know this back number here. Oops, I should use a pen so you can see. This back number here is the y-intercept. Well, here's the y-intercept in pink. I know my slope is this number in front of the x, which looks like it's a 1. So it's up 1 over 1, up 1 over 1. So I know I graphed it correctly. I just kind of confirmed it. So this is kind of putting everything together. Today you're going to get a rule. You're going to make a function table. You're going to make some ordered pairs here. You're going to graph it, and then you're going to check, did I graph it right, using what we learned last chapter. All right, so let's look at page 267, if you guys can flip there. And here is our function this time, y equals x plus 2. All right, so I'm going to just kind of write that over here wherever I have some space. And it says I am going to use these inputs right here. You can see I'm going to use 0, 1, 2, and 3. So I'm going to take they kind of did this for you. Instead of an x, I'm going to plug in a 0. So 0 plus 2 gives me 2. So my first coordinate is 0, comma 2. Okay, my next coordinate, they plugged in a 1. So all they did is come right here, and they said, okay, plug in a 1 instead of that x. 1 plus 2 gives me 3. Oops, I should write that in pen. 3. So my coordinate is 1, comma 3. The next one, they plugged in a 2. 2 plus 2 is obviously 4. So my next coordinate is 2, comma 4. And then finally, they plugged in a 3. 3 plus 2 is 5, so it would be 3, comma 5. So now I have my coordinates. X plus 2. Oops. All right, so now we are going to graph these points. So I'm going to start with 0, comma 2. So again, remember, the first number tells you left or right. So I'm not going to go left or right, but then the second number is up and down. I'm going to go up 2. So 0, comma 2 is right here. So I just graphed that one. All right, 1, comma 3. That means I need to go to the right one, up 1, 2, 3. That would be 1, comma 3. 2, comma 4. I'm just going to use this so you can see. I'm going to go right 2. So I start at the middle, go right 1, 2, up 1, 2, 3, 4. Should be right there. Okay, and then 3, comma 5. I'm going to go right 1, 2, 3, up 1, 2, 3, 4, 5. Put my last point there. Okay, I'm going to connect this and put some arrows. Okay, now I'm going to think about what I know. So my equation for this was y equals, I just got to go back quick. Apologize for that, x plus 2. So let's just confirm that this is right. So my y-intercept is 2. Well, if I look at my graph, my y-intercept is right here, and that is 2. My slope is right in front of the x, which is, it looks like a 1 over 1. So if I look at this, it's up 1 over 1, up 1 over 1. So I know I did that correctly too. Now, here's a question for us. Is the point negative 1, comma 1 a solution to this function? Well, there are two ways that we can check that. First way is we can look and see, is that actually going to be on the line? Well, I'm going to graph it. Negative 1, comma 1 is right here. Well, using my pattern, it looks like it will be on the line. There's another way to test it, and I want to show you how. So if you have your equation, and they said negative 1, comma 1, I'm going to take that negative 1, and I'm going to put that where the x is right here. And I'm going to take that 1, and I'm going to put it where the y is. And I'm going to see if it works. Well, let's see what happens. I get 1 over here, 2 times, let's just say a plus there. Negative 1 plus 2 is 1. 1 equals 1. So yes, it is a solution. So I checked it two ways. I checked it on the graph, and then I plugged it in to see if it worked. And it worked both ways. All right, if we look at the next one, I have a function up here, y equals negative 3x plus 4. It says to make a function table and then graph it. So I want you to pause the video, and I want you to fill in the function table, and then I want you to attempt to graph it. And then when you are done, you are going to check it. So start by doing the table. All right, so if you did this, I'm going to do my work down here. I have negative 3 for x plus 4. Negative 3, and then I plug something in, plus 4. I'll start by plugging the negative 1 in. Well, I know a negative times a negative is a positive 3, plus 4 gives me 7, so we should have got 7 here. Okay, if I plug in a 0, negative 3 times 0 is 0, plus 4 is 4. Okay, now I'll do negative 3 times 1 plus 4. I get negative 3 plus 4, which gives me 1. Again, you should have this done already, so I'm going through it quickly. And then negative 3 times 2 plus 4, which is negative 6 plus 4, is negative 2. So now my coordinates are here, negative 1, 7, 0, 4, 1, 1, and 2, negative 2. Okay, so to graph those, negative 1, 7, so I'm going to go left negative 1, and then up 1, 2, 3, 4, 5, 6, 7. I'm going to put my point. 0, comma 4, I'll start at 0, and then up 1, 2, 3, 4. There's my next point. 1, comma 1, to the right 1, up 1, and then 2, over 2, and then down 2. Okay, here is my line. Okay, now to check that we did this correctly, let's test. So here was my equation, negative 3x plus 4. Okay, let's start with the y-intercept. Where does it cross? It should cross at 4. Well, this does look like 4 here in green. And then my slope, if I look at that, it looks like it's negative 3 or negative 3 over 1. So let's test it. I'll just do it in blue. So I'll pick 2 points. It looks like I go down 1, 2, 3 over 1, down 3 over 1. So I have a good graph. All right, so let's go to the apply problem on page 269. It says a taxi service charges $2.50 plus 75 cents per mile. It says the function y equals 75x plus 250 represents the total cost y, okay, maybe you should underline that, of a taxi ride for any number of miles, x. Okay, so it says if Adriana rode 10 miles in the taxi and Alonzo rode 15 miles, how much more did Alonzo spend on his taxi? All right, I want you to go ahead and try to solve this problem any way you want to solve it without my help. Okay, please push pause, and when you're ready to watch the solution, push play. All right, so if I was doing this, I know here is my equation, y equals 0.75x plus 250. And then I like to kind of write what they told me everything stood for. So it says the total cost is y. So this y is the cost, and then the miles is x. So here's the miles. So let's start with Adriana. It says Adriana rode 10 miles. Well, if she rode 10 miles, the miles is right here. So instead of an x, I'm going to put a 10 here and see how much it cost her. So it's 75 cents per mile plus the 250. So I need to do 0.75 times 10. Okay, so if I type that in on my calculator, it's 7.5 plus 250. Okay, if I add that up, I end up with $10. So it costs her an even $10 for her ride. All right, now I'm going to do the same thing for Alonzo. So same equation. Now this is just one way to do it. So I'm going to plug in, he rode 15 miles. So I'll put a 15 there for x. And now I'm going to work this out. All right, if I work this out, I end up with a total of $13.75 because 0.75 times 15 was $11.25, and then plus the 250. Okay, so now I have how much both of them had to pay. It says how much more did Alonzo spend on his taxi ride? Well, if he spent $13.75 and she spent $10, it looks like they spent $3.75 more on the ride, as long as I didn't make any mistakes, and hopefully I didn't. All right, let's go ahead and try the check on page 270. Why don't you go ahead and give it a try without my help again, and then you can push play when you are ready. All right, so question, hopefully you read it a couple times. It says an elephant weighs 200 pounds at birth and then gains approximately 2 pounds per day. So they kind of wrote an equation for you already. It says the function w equals 2d plus 100 represents the weight, w, of an elephant on a given day, d, during his first year. How much more does an elephant weigh on day 60 than on day 5? All right, so I always like to just write the equation first. W equals 2d plus 200. And again, I like to write what things stand for so I know. So it says W is the weight. Okay, so to find the weight of the elephant, and it says D is the days. So I just like to put that there. Okay, so it's 2 pounds per day plus the 200 that it weighs at birth. Okay, so it says how much does it weigh on day 60 than day 5? Well, we better figure out their weights for both. So let's do day 5 first. So for day 5, I'm going to do, it gains 2 pounds a day for 5 days. So I'll plug in a 5, plus that 200 it started out weighing. Well, 2 times 5 is 10, plus 200 is 210 pounds. So on the 5th day, it weighs 210 pounds. All right, let's find day 60. So on day 60, it gains 2 pounds every day for 60 days, plus that 200. Well, 2 times 60 is 120, plus 200. If I add that up, I get 320. Okay, so that's on the 60th day. Obviously, it weighs a lot more. Now it says, how much more does it weigh? Well, how much more? I'm going to have to subtract. So I'll do 320, take away that 210, and I end up with 110 pounds more on the 60th day compared to day 5. I should even add that more. All right, so now I want you to practice what we learned the last 2 days. So you are going to go to page 271 and 272 in your math book, and you're going to complete numbers 1 through 5, number 8, 10, and 11. So use your time wisely to work on this. This is homework. If you have questions, I will be in the class kit, and I can help you out. Have a great rest of your day. You can also ask Mrs. Schutte because she knows how to do it.